Hi everybody, so today we're going to be looking at systemic lupus erythematosus and basically what causes it. Okay? And then we're going to go into what it does, and then what's going to happen is we're going to talk about the signs and symptoms and how we diagnose it. So systemic lupus erythematosus, systemic basically means it affects organs in the body. Okay, it can affect whole systems or it can affect the whole body, right? But anyways, it's going to affect organs in the body. All right. Lupus means wolf, so basically it's going to look like a wolf bit the body, okay? And then we have erythematosus. This means there's a redness of the skin. So what's going to happen is in some cases it's going to look like a wolf bit the skin, I guess is where they got the name from. It's also systemic lupus erythematosus is more commonly known as SLE. So what's the causes of this? Let's look at the causes. Well, first, there's an environmental portion to this and a genetic component to it. All right, and a genetic component. So let's look at environmental real quick. The most common cause is going to be UV rays from the sun, right? That's going to come down, it's going to damage cells, and then what's going to happen after it damages the cells they'll go through apoptosis, which we'll talk more about this in a minute. And then what happens is your immune system's defective because of your genes, and then you can't clear out those cells, so your body views them as an enemy, and then what your body's going to do is build antibodies against your own body. So that's one thing is UV rays. It can be due to an infection. Most commonly, it's going to be from the Epstein-Barr virus, especially if you get lupus when you're a kid. It can be due to hormones. The most common hormone is going to be estrogen. So obviously, this is more likely to affect females, especially females of color. Right, but estrogen, women are 9 to 20 times more likely to get this, depending on what sources you read. It's between 9 to 20 times more likely to get this. Now, during childbirth years, when estrogen levels are higher, once you get past those years or before those years, women are still twice as likely to get that. So during the childbirth years, they're 9 to 20 times more likely to get systemic lupus. You can get it from smoking. You can get it from certain medications, okay? And then, like we said, there's a genetic component. So basically, your genes affect the immune system. What's normally going to happen is you're going to have a decrease in complement proteins. And if you recall, complement proteins, what they do is the complement proteins basically come together and they make like a little straw-like structure that then goes into the cell membranes of cells and allows fluids to go in, and then the cell increases in size and explodes. So now let's take a look at the pathophysiology of systemic lupus. Okay, so let's take a look now at what happens when someone gets SLE. So like we said, there's a genetic component and there's an environmental component. So what I'm going to do is I'm going to draw the sun over here. So let me go like this. And I'm going to draw the sun because that's the most common cause, right? So here's the sun, right? And the sun's going to release UV rays. Now, what's going to happen is the UV rays are going to come down and they can hit cells. So I'm going to draw a cell like this. Okay, this is my cell. And then, as you know, if you're watching this video, you probably already know this, that inside the cell, you have DNA. Right? There's the nucleus, and inside you're going to have DNA. So what's going to happen is when the UV rays hit the cell, they may damage the cell, right? If you've ever had a sunburn, you know exactly what I'm talking about. So they may damage the cell. Now what's going to happen normally is the cell will repair itself. But if the cell can't repair itself, what it will do is it will set itself up for something called apoptosis. Apoptosis is programmed cell death. Now remember, this is a healthy cell we're talking about. So we're going to get programmed cell death, right? So what's going to happen is the cell's going to come apart, and we're going to have fragments. We're going to call these apoptotic bodies. Right? All of these are going to be apoptotic bodies. And then what's going to happen is this DNA that's on the inside of here is going to be exposed to the outside environment, right? And so we'll get different proteins that are inside the nucleus out here, and I'll talk more about those in just a minute. So now what's going to happen is a macrophage or white blood cell will come along, and it's basically going to clear this. It'll basically eat all these, take them. It's going to present them on their cell membrane. It's going to go to the lymph node. But normally it's ignored because the body's healthy and it recognizes these as being self-antibodies or self-proteins, right? So normally it's going to be ignored. Here's what happens when someone has SLE. Same thing's going to happen. We're going to get damage to the cell. It can't repair itself. So now we're going to get apoptosis again. But in this case, here comes my apoptotic bodies, right? So I'm drawing 4. Obviously, you know it's going to be more than 4. I'm going to have those proteins that were inside the nucleus. Here's some double-stranded DNA. I'm going to put some over here. And then I'm also going to have just some other fragments of the DNA. I'm going to have histone. We're going to have ribonucleoproteins. I'm going to put something down here called Rho. And let's label these. So here's some histones. If you remember, histones help hold the DNA together. And then this is going to be double-stranded DNA, right? Now, the DNA is broken apart, but you still have the areas that are double-stranded. And then I have other fragments of the DNA also. So now what's going to happen is I'm going to have another macrophage, another white blood cells, come by. It could be a dendritic cell. And it's going to phagocytize this, right? But what it's going to do is, first of all, there's going to be a deficiency in this. And usually it's a deficiency in the complement system. So if you recall in the complement system, the deficiency is going to be in protein C1, C2, C3, or C4. Now, it's not all of these. It can be, but it's not all of these. Okay? But we have a deficiency in complement proteins. Okay, so now what's going to happen is this white blood cell can't clear all this. So what it's going to do now is it's going to clear some of this. It's going to phagocytize it, right? It'll take those over to the lymph node and then they'll be ignored. But now I'm going to get another macrophage that comes by, and it's going to see this, and it's going to think that these are antigens. It's going to think these are foreign. It's going to think that these are not part of the body, right? And that they need to be attacked. So this is going to now phagocytize all this, just like we did over here. It's going to break this down, and now it's going to present fragments of this on its cell membrane. Remember, these are antigen-presenting cells, so it's going to present these on its cell membrane, right? So here they are here, right, being presented on the cell membrane. Now what's going to happen is these are going to go over to a lymph node. So let's go like this. Okay, and these are going to come over to a lymph node. So now what's going to happen is, let's say this is my lymph node. So now this macrophage, this antigen-presenting cell, because remember these are antigens, are going to enter into a lymph node. And then what's going to happen, so here it is, right? And then what's going to happen, let's just say these are all my antigens here. I'm not going to use the different colors just to save time, okay? But this is going to be my macrophage. What it's going to do is it's going to attach to a naive T cell, right? Here's my naive T cell. And then the naive T cell is going to go on to become a T2 helper cell. The T2 helper cell is then going to go and it's going to activate B cells. Okay? Now, the B cells can do 2 different things. One, what the B cells can do is they can form memory B cells. And what memory B cells are going to do is they are going to remember these antigens as foreign. So when you come in contact with them again, this is going to make antibodies, right? So it'll make antibodies to this when you have something else. And this is going to lead to the flare-ups that you have when someone has SLE, right? When someone has lupus, that's going to lead to the antibodies. So it's made those, right? The other thing the B cells are going to do is they can become plasma cells. And when they become plasma cells, what the plasma cells are going to do is they are going to make antibodies also. But remember, these antibodies are now attacking our own body. So these are going to be called autoantibodies, right? Because they're attacking our own body now. So here's what these antibodies are going to do, is a few different things. Okay, so remember, an antibody looks like a Y, and what I'm going to do is, where's my blue, is it's going to go, and then this is going to be, this, in this case, it's going to be a nuclear protein, right? So that's going to be a nuclear protein that belongs in our body. It could be, like I said, the double-stranded DNA. It could be the histone. It could be the Rho. It could be SM. It could be mRNP. But anyways, it's going to attach to that, okay? This antibody. So this antibody now, because it's going after a nuclear protein, it's going to be an anti-nuclear antibody, because it goes after the proteins that are in the body, right? That are in our own DNA. So now, for short, we're going to call these ANA. For short, anti-nuclear antibody, okay? Now, here's what these can do, and I'm going to show you some other ones in just a minute. These can come over, right, and they can do several different things. So I'm going to just come all the way over here. They can go onto cells, and remember, when I have the antibody with the antigen, this is an antigen-antibody complex, or also known as an immune complex, and it can be deposited on a cell. So in this case, it's going to be deposited on a cell. So this is my anti-nuclear antibody right here, right? That's it right there. Now it's going to label this for attack, and it's going to be attacked by the complement system. If you recall, I mentioned the complement system earlier, and I said that we have a deficiency in this. It doesn't mean that it doesn't work at all. So the complement system now is going to start releasing, it's going to release some cytokines to cause inflammation, but it's also going to poke holes in this, so now fluids can come in and basically cause the cell to blow up, right? It's going to expand, just like blowing up a water balloon, it's going to expand. The other thing this can do too is on some cells, you can have proteins that are on the outside. So let's say this is a protein on the outside of this cell, on the cell membrane, and now this can attach to this also, right? And what it's going to do is attach onto there. Now, these proteins that are on the cell membrane, these can be on several different things. It can be on any cell, but also it could attack other types of proteins, cell membrane proteins such as cardiolipin, right? Which cardiolipin is usually found on mitochondria, right? It could be found on red blood cells, or it could be found on plasma cells. And so now what's happened is I basically have my immune system attacking my immune system, right? So that's a protein that's on the outside on the cell membrane, right? The other thing that I could have is on the inside, I could have another protein, which we're going to call Rho, just RO, okay? And this is a ribonucleoprotein, but this can also attach onto this. And this is, again, this is a cytoplasmic protein. So this can actually attack basically anywhere, right? But now it's, but the main thing it's going to attack is the nuclear proteins, the DNA and all that was inside the nucleus. But these are other ones, right? This is in the cytoplasm, this is on the cell membrane. The other thing this can do is on your white blood cells, you actually have something called an FC receptor. And so what this can do is it can actually attach onto the FC receptor. And again, when it does this, let's go like this and just say this is my FC receptor right there, okay? So when it does now, and all of these, we can release something called cytokines. Now eventually, and remember, these cause inflammation, right? Cytokines cause inflammation. So eventually what's going to happen is when we have these cytokines, they're going to go and destroy more cells. So they're going to go and they're going to destroy cells, right? which is eventually going to come back and lead to more cytokines being released, which is then going to go and destroy more cells. So you can see it's a cycle. Now, eventually the body catches on and it will stop all this, right? It'll stop all this inflammation. And then what's going to happen is the person's okay for a while. The main thing in lupus is you want to prevent the flare-ups. So again, if someone goes out and they do something, or they take a certain medication, or they're under stress or pregnancy, right? Those can cause a flare-up, and then these are going to be activated and basically cause all this again, right? We're going to get the anti-nuclear antibodies and the other things that go on there too. So that's basically what's going to happen pathophysiological-wise in lupus. Now we're going to talk about basically how to diagnose lupus, okay? So remember, you're going to have 4 of 11 symptoms in order to get lupus. So we'll take a look at that now. Okay, so let's look now at how we diagnose lupus, okay? So when it comes to lupus, again, lupus can affect anywhere in the body. So because the symptoms are so widespread, you're actually going to want to have at least 4 of 11 symptoms. So we're going to have 4 of 11 of the following symptoms in order to have lupus. So the most common one is going to be a malar rash. So the person goes out in the sun and they get this rash. This rash is going to go across the bridge of the nose and down around the cheeks, and it's known as a butterfly rash, okay? So that's the first one. The second one is also something known as a discoid rash. And in actuality, you could just have this as its own form of lupus. So you're going to have a discoid rash. And in this case, there's going to be plaques, and there's going to be redness, and there's going to be scarring on the skin, okay? And redness, okay? And what happens with this is where I think they get the wolf bite thing from, because it looks like a wolf bit the skin. The third one is any other photosensitivity rash that you have can actually lead to this too, okay? So any other photosensitivity, you could actually get ulcers on mucous membranes, right? So you can get ulcers like in the mouth and things like that. Okay, so you can get the mucus on the mucous membranes. You can get it on the serosa. And what would happen here is you can get things such as pruritus, which is inflammation of the cavity that surrounds the lungs. You could get pericarditis, which is the covering around the heart. Okay, you can get arthritis. Usually it's going to have to be in 2 or more joints. Okay. The other thing you can get is neurological conditions such as seizures and other things. It can affect the kidney. Where am I at? Number 7. Number 8, you can have kidney problems, right? Glomerulonephritis, abnormal proteins in the urine. You could get, if you do blood work, you could get, you can look for anti-nuclear antibodies. Remember, these are the antibodies that are going to attack the proteins that are found inside your nucleus and inside your DNA, right? But this is not that specific. You get this with other conditions as well. More specific, you could get anti-Smith proteins. And anti-Smith proteins are basically going to attack ribonucleic proteins. And then you can also get anti-double-stranded DNA antibodies and anti-phospholipid antibodies. So this is obviously going to be if you do blood work, okay? So you're going to have antibodies that are against double-stranded DNA and against the phospholipids. So that's basically the type of test you're going to do to see if someone has lupus. So thank you so much for watching. If you enjoyed the video, please hit the like and subscribe button, and we will catch you next time.